Yes.
Yes, try it.
Yeah, hello? Can you hear me?
No, dice your mic is muted by your system setting. Go to
Good
your
morning.
computers.
Yes, we hear you.
Hi, Laura. I can hear you.
Do you hear me?
No,
No.
allora...
And you?
Yeah, I hear you.
Ah, lei mi sente?
Allora cambia anche il
Guarda, poi voi non mi vedete.
audio. No.
Ma...
Speakers.
Ah, che strano, guarda.
Sì, l'ho visto. Si vede che tu parli col microfono acceso e non fai eco.
infatti.
Cioè, doveva fare eco come mi...
Laura, can you say something to test
Hey,
the
do you hear me?
speakers?
Do you hear me?
Yes.
yes.
Perfect. Okay. So
And
it's now working.
Okay, perfect.
Finally.
yes.
It's okay for you to
Maurizio, now can you hear
because we
me?
are still waiting for the first presenter to connect where did you know?
But at 9:20, not now, right?
Okay, because somebody is going to connect for you.
Maurizio can't hear me.
Sì, lei vedi che scrive.
Sì.
We can try another one online if you
Maurizio. No, I can hear you. So I don't know why.
Sì, però dobbiamo semplicemente... Secondo me è quello. Univ HDMI PCM.
Speakers, ricordatevelo per oggi.
Sì, ma avete l'HDMI collegato?
Hi Maria.
Ah, non ci vedo.
She can hear you. Yes.
Dove è la telecamera?
Maurizio, it's not okay. We can try to...
Ah, lì.
No, ok? Sì.
Ciao Maria.
Dov'è?
We have some problem. È lì.
Ah,
Ciao.
Anzi, può abbassare.
Ci senti Maria?
sì.
I am here.
Di solito
Ok,
solo
Maurizio, abbiamo
non si
qualche
sente.
problema di audio, microfono e anche di telecamera evidentemente, quindi li stiamo risolvendo.
No, camera is must be like that.
Okay, we can move the camera.
So how the camera can focus on the presentation?
Yeah, normally.
The presentation is presented.
Maurizio sharing.
Is sharing, so it's
Oh,
not a
share.
problem.
Yeah.
We can see
Open your mic, please.
Secondo me se vai nella camera qualcosa possiamo fare.
Qui?
Sì. No?
No, fa così.
Ecco. Tipo
Interventi
prendi
in camera.
quella.
No, we
No.
can change because it will present.
To share presentation.
Yes, but we want just to say hello to everyone online
Okay.
with our face. Okay.
And the other is this one, so then we can move.
And the camera cannot be moved.
Okay, so I can use my mouse.
Yeah. Hopefully.
Not really,
Yeah.
but with the, like, normally.
And when I present, I can see the comment here. I don't
That
need
is
it.
the technical.
Yeah, but the presentation comment will be here.
Action, I think so.
Yeah.
So you can move from.
Can you
Perché così sensato
It's 5 minutes we can start. Yeah, that's fine.
So you are
9:20.
time ready.
Vogliamo salutarli? O ci mettiamo
Yeah.
Diana? Sì.
Okay.
Ciao.
Hi everyone, how are
Ciao.
you? Hi everyone.
Hi everyone. We are here today. Non so se ci sentono, se devo dire la verità.
You can hear us?
Yeah, we
Yeah,
hear you.
okay.
Yeah.
Okay, we're going to start
Morning.
in 5 minutes with the second presentations because
We're waiting for the first.
we are waiting for the first. Maybe we can switch with
The order.
the order. Yeah.
Where is your presentation?
I don't know, did you
I need
download?
to do this.
Okay, so.
Floor is yours.
Sì.
No, ma facciamo.
No, no, devi solo scaricare
Sì.
ICCSA.
Carta mia.
Do you want to
No, it's pattern, the last one.
Pattern.
Yeah.
País a base.
Pattern alla base.
A la base.
Yeah.
A la base.
Is this one?
Yeah.
You can also check, you want the presentation mode?
Yeah, but I want to be presenter, so with all.
Okay.
Then we try.
Yes, it is possible.
Questa è un'ottima notizia.
You can
Abbiamo le presentazioni.
try this if you want.
Vedo che me le metterò tutte.
Now we are going to share.
Sì, non sono andata alla conferenza adesso.
Yeah. Oh, I don't know.
It's not shared, I think.
Can someone share some picture? I'm gonna record the presentation.
Yes, okay.
But please share some pictures.
Yes, okay. So we are.
It is sharing
Posso
now.
dire che sei la nostra social media manager? No.
Comunque sono andata a ricontrollare l'iscrizione, era student e postdoc, quindi non sono.
Ah,
Sì, sì.
sì. Postdoc, no, perché davanti all'organizer le faccio, no, ma tu non sei più student. E lei no, perché io l'ho detto in maniera per dire, no, ma non ti sbagliare che sei ancora student.
Sharing your screen?
Era un danno.
No. Starting is always difficult.
We have always different problems and all the universities is normal.
I don't think it's shared.
No, because you need the
red.
framework in orange.
No. I think it's sharing.
Yes.
Sharing? Can you see the presentation? So it could be also different in this case. Yeah.
Yes, I am. Yes, you are sharing. I am in the YouTube live stream.
Okay. Okay. Quindi no red rectangle, no red frame.
No, no.
Ok.
Different. No, it's this way.
Ho
Okay.
detto framework prima, ma era frame.
Frame. Yes. Can you see if it's changing?
Yes.
No, no, not changing yet.
Yes.
Maybe in few.
1 second ago, yes. In this moment,
Maybe
no.
not.
No, not anymore. I don't know why. But maybe just in the YouTube. Yes, now yes.
Yes. Oh,
In
no,
a second. Second?
I think
Ah,
maybe it's a delay.
20 seconds later.
After 20 seconds.
Scusate, guardate che nella GC Room non è condiviso.
Secondo me, infatti.
Però su YouTube sì.
I think the others will get confused because you flip the slides, so they maybe they think they cannot hear well. You know what I mean?
I think we have the microphone on so they can understand. We are trying to.
Yes, I wrote also
To
in
solve
the
the
chat.
problems.
Yeah.
So this
Because my colleagues send me, oh, we cannot hear you well. They thought that I flip slides.
Someone is speaking?
Yeah.
I think it's okay now. Can you see?
No.
Look
On
at this.
YouTube no.
This is
Maybe
the
because you're
room.
here.
We can see.
No, because we are. I'm on YouTube channel and she is in the classroom. Let's see classroom.
That's you?
But
Yeah, take your time. So what's the YouTube channel?
it's in the program. I just click on the link on the program. Here you see. To watch the session, go to the YouTube live stream.
So you have here to register?
No, just to, no, I cannot register, I think, but
No,
we have this link in the conference, or if you are presenting, it's your room, so I just.
Now it's sharing. Yeah,
Okay.
So, can I
Shared
send
now.
the link to my,
No,
I think that if you click on this and copy and paste this,
now it's sharing.
this is the link.
Now it's sharing, maybe without delay.
there's, the person that we can,
To manage this, solving this.
Quite long, I hope to don't do mistakes. Because you see, it's
just like,
okay. Okay, so we need to.
Entire screen, maybe? No. No, non si vede.
can you
refresh?
refresh your page, please?
No.
Di comprarsi una nuova
It's nothing there.
Yeah, participant.
I'm going to.
Yes, because it's shared.
Yes, share, but we have
To manage this.
W.
M.
Yeah.
I have it. Thank you so much. Try it.
Otherwise, we can use my laptop.
It's unavailable, shared.
So can you but you know why? Because maybe it's because we paid to enter in this.
You pay?
We all in the inscription. I don't know if it is something open or you need to be inscribed in the conference. Yes, it's like
Oh, she got the.
Yes, adesso funziona su YouTube, funziona. Secondo me non puoi averlo sia su YouTube che nella Jazzy Room. Quindi
Ma per gli altri presenti?
Sei scritto tu.
We are already.
Sì.
ok.
Ciao, Damiani.
Hello.
Is this one?
Questo è mio, non ho dentro Jitsi, ma non si vede la presentazione.
It's expanded, I don't know, expanded.
Yeah, extended. Screen.
And the entire?
Yeah.
No.
No, non si vede, can use our
Su YouTube sì, on YouTube is visible. Ah, su Jazzy no. Però
So YouTube
sì, adesso
on
prima,
YouTube
adesso
it's
non-
okay because here inside the university, if you use a DROM, they block some ports, some network ports. So you should use only this widget. You cannot use
This
your
is what I
own
told you.
device widget.
Okay.
That's what I told you,
Now
because
they
you're here.
They can see it's shared with the participants.
yes.
Okay.
This is the room.
Hopefully. H, 4H.
Okay. If you see on YouTube,
Yes,
it's
on
okay.
YouTube is okay.
Okay.
Grazie.
Yeah.
So we can start.
Yes,
Okay.
conferma. Finally.
Finally. Okay. So.
Ah, sì, loro la vedono, vero?
Sì?
Okay. Solo
Ok.
non la vedono.
So mi sentono?
Okay.
They can hear me? Hopefully. Okay, so good morning, everyone. Sorry for the technical issues and welcome to the session for H. It is a combination of different workshops. I saw also Maria Cerreta, that is the chair of the MEUE, the last part of the session. And a part of the session is the evaluating in area potential that is for the editions. So with me, there's Emanuela Baudengo, Alice Barreca, and Giorgia Malavasi. but I don't want to spend more time because we are still late. So we immediately start with the second presentations entitled An Optimized Reactive Personalized Restaurant Recommendation System Using Content-Based and DB-Scan Clustering in Google Cloud Platform. Yes, long title. And I leave the floor to Faten Alabas. So the floor is yours.
Thank you. Hi everyone, good morning. My name is Faten Al-Abbas from Pittsburgh University, Boston, Massachusetts. It's my pleasure to present our research entitled and optimized reactive personalized restaurant recommendation system using content-based filtering and DP-scan clustering in Google Cloud Platform. Thank you for attending and sharing with me, and I am looking forward to share our work with you today. So this presentation covers the research motivation, like why we think about this model, objective purpose, architecture, and some data preparation process with the DP-scan clustering and recommendation model, ranking formula, and some experimental results and future work. And I hope that I can cover all this in the limited time. So actually, the motivation for this research comes from a real life problem, and I like to share you my story with this research. Actually, while visiting my home country, I noticed how difficult it was for the family or friends to agree on restaurant. Even with many recommendation apps available, after trying several recommendations, I'm still feeling like disappointed. We ended up saying, maybe we should just trust my grandmother recipe instead. So that humorous moment inspired an important research question. Can we build a smarter restaurant recommendation system that better understands user preference and location? This question inspired the development of a proposal model. So with the growing of number of the restaurant and location-based services, finding the right restaurant has become more difficult. So the recommendation system helps users identify suitable dining option while reducing the search time. So to generate accurate recommendations, several factors must be considered, including cuisine type, price, location, ambience, and dietary restriction and user preference. Actually, these challenges motivate the development of our personalized restaurant recommendation system. So existing restaurant recommendation systems still face several challenges. They often provide recommendations based on basic user preference without fully considering dynamic filtering attributes and location-based information. In addition, recommendation quality is affected by the cold start problem, where limited data is available for a new user and a new restaurant, and a long-tail problem where recommendations focus mainly on popular restaurants, while less popular options receive limited visibility. So to address these challenges, the proposed research integrates user preference with location-aware information, improve recommendations for a new user and restaurant, to promote less popular restaurants, and enhance overall recommendation accuracy. So these objectives are achieved through the reactive recommendation framework that we're going to discuss today. So the main keys contributions of this work focus on personalized recommendation, location-aware clustering, and enhanced ranking mechanism. First, the content-based filtering capture user preference. Second, the GPS-based DP-scan clustering groups nearby restaurant and reduce the search time. While the last one, which is the hybrid ranking formula, combines similarity and distance measures to generate more relevant recommendations. Actually, the proposed system consists of two main components, the front end which captures the user location and the preference through web or mobile applications. The back-end implement on Google Cloud platform and Firebase process user requests, retrieve restaurant information, and generate personal recommendation. This architecture enables scalable, real-time, and location-aware restaurant recommendation. So to achieve this purpose, we collect a data correspondingly in order to build our model. So the dataset actually process, if we're gonna go to the EDA for our journey, so the data set and the processing journey consists of three main stages. The collection of the data, restaurant data were collected using the GPS, Google Maps, and surveys, while through the processing, then we convert from the Excel and CSV formats into the JSON objects. Finally, storage the database were stored in Firebase on Google Platform, providing scalable and efficient access for the recommendation system. If we try to answer some questions about the metadata of our data, like who and where, when and what and how, so the data determines information about 315 restaurants collected in 2025 around Al Nahrain University in Baghdad, Iraq. It includes restaurant attributes such as rating, GPS coordinate, cuisine type, and service options. The data were collected using location-based services and validated by the research team. The dataset is also designed to grow dynamically as the restaurant information becomes available. After collecting and validating the dataset, several pre-processing steps were applied before the building of the model recommendation, which I will discuss next. So this is in this stage for the user modeling and the pre-processing. So the stage converts, or the model, converts user preference and restaurant attributes to machine processable representations. User profiles are modeled as query vector, while restaurants are presented as features vectors. During the pre-processing, categorical attributes such as cuisine and restaurant services were encoded into binary vectors using one-hop or multi-hop encoding. Numerical attributes such as rating were normalized to values between 0 and 1 using min-max normalization. After pre-processing, each restaurant is represented as a feature vector, while the user prefers from a query vector, enabling the system to compute the content similarity efficiently, then enabling efficient similarity matching and personalized recommendation generation. So let's now walk through the recommendation process step by step. So the process begins when the user submits restaurant preference along with the current GPS location. The system retrieves the corresponding user profile from the cloud storage, then identifies nearby restaurants using the deep scan clustering based on the geographic coordinates. This clustering step actually reduces the search space by focusing only on relevant geographic region. Next, the restaurant for within the selected cluster only, the system computes both content similarity and distance similarity. These measures are combined using the proposed weighted ranking formula to generate a final score for each restaurant. So the restaurants are then ranked in descending order, and the top 5 most relevant recommendations are selected and delivered to the user device through the cloud platform. Having reviewed overall workflow, let's now examine the core algorithm that drive each stage of the recommendation process. The effectiveness of the proposed recommendation model depends actually on three algorithms. First, the DP scan. So the DP scan groups restaurants based on the GPS coordinates, reducing the search time from 315 restaurants to about 61 restaurants per query. Second, the Manhattan distance measures the geographic proximity between the user and nearby restaurant, while the third, distance normalization, converts the distance into similarity score between 0 and 1, giving higher score to closer restaurant. Together, these algorithms improve efficiency and improve manifold similarity score for the final ranking stage. So this raises an important question. Why were these three core algorithms chosen to build the proposed model? So the selected algorithm, in a brief or in summary, so the selected algorithm better addresses the challenges, while alternative methods were not selected due to their limitations, like the K-means algorithm, we can use it in the clustering, requires predefined clusters and struggles with irregular spatial data. Euclidean distance, we use Manhattan distance instead of Euclidean because Euclidean distance ignores actual road travel, while the road distance cannot be fairly combined with similarity score for ranking. So after reducing the search space using the DB scan, the system generates personalized recommendation in two stages. First, cosine similarity measure how will each restaurant match the user preference. And this is the effectiveness of the cosine similarity. Second, the proposed weight ranking formula combines content similarity with normalized distance similarity to compute a final recommendation score. So the parameter alpha balance the importance of the user preference and geographic approximately, while regeneration efficient lambda prevent excessive bias toward either factors, ensuring balance and offset ranking. Based on experimental evaluation, the optimal values were determined in our model, like alpha is 0.6 and lambda is 0.5, providing the best balance between semantic relevance and spatial proximity. Finally, the restaurant ranking, the restaurants are ranked according to their score. And the top 5, as I mentioned, the top 5 recommendations are returned to the user. We will now examine some experimental results and sample of these recommendations. So, yeah, so I tried to present the top 5 personalized restaurant recommendation generated by the proposed system for the user. Actually, we take the user located around the Al-Nahrain University in Baghdad. The recommendation process begins by identifying the user GPS location and preference, what the user prefers. The recommendation engine then applies the DP scan clustering, similarity computation, and weight ranking formula to identify the most relevant one. The 5 highest ranking restaurants are returned in descending order of their weight score with these 5 restaurants. So the Chili House ranked first, followed by Qasr Karam, and so on. This is the name of the restaurant around this area that comes with the user preference. In addition, a restaurant ranking ranks, the system provides useful information such as rating, location details, and available services, including dine-in, takeaway, delivery, that the user can be sure that this selection comes with his preference. This result actually demonstrates the system ability to generate practical and personalized recommendation based on user and preference and geographic proximity. So if we come to the interpretation of recommendation result, which is generated by the process system, the table on the left shows the top 5 restaurants from 6 recommended restaurant ranking according to the final weight score. So as shown, the chili house, that the one that the best match with the user preference and location, achieved the highest weight score of approximately 0.982 and was therefore selected as the best recommendation for the target user. The bar chart shows, of course, the difference between the ranking weight for the top 5 we use it as in the model. So after we examined an individual recommendation example, let's now evaluate the overall performance for the proposed model through experimental results. So this table compares our proposed model with the 3 baseline methods using 5 standard recommendation metrics. The precision, which is the recommendation accuracy and recall, retrieve or relevant restaurant, the F1 score, balance of the precision and recall, while the NDG ranking quality. And the coverage recommendation, it refers to the recommendation diversity. As shown, our model achieved the highest score across all matrices. So, to summarize the key findings for the experimental evaluation, the proposed recommendation model consists outperformed the best baseline across all evaluation metrics. It achieved improvement of 18.8% in precision and all the other scores. These results demonstrate that integrating deep scan clustering with content-based similarity and distance-aware ranking produce more accurate, better ranking, and more diverse restaurant recommendation. Overall, the proposed model achieve about, actually the improvements from 12.5 to 19.5% over all strong test baseline. While all metrics improve, the coverage matrix provides an especially interesting insight into how the proposed model addresses the long-tail problem. Let's examine these results in more details. So here I highlighted one of the most important findings of our evaluation, which is the coverage. The coverage measures the proportion of unique restaurants that can be recommended by the system. A higher score value indicates greater recommendation diversity and less repetition of the same popular restaurant. As shown, the proposed model achieved a coverage about 0.63, which is the highest among all baseline methods. This represented an improvement over the distance-based, rating-based, and content-based approach. This result actually demonstrates that the proposed model is more effective and exposing users to a wider variety of restaurants, thereby reducing the long tail problem and improving the overall recommendation experience. Having discussed the recommendation diversity, let's now just look at the deep scan clustering contributed to improve the efficiency of the recommendation process. Again, so after applying the DP scan clustering to our dataset, using the restaurant GPS coordinate, DP scan automatically and define the geographical relevant cluster without requiring a predefined number of clusters. So the clustering process reduced the candidate search space from 315 to 61 restaurants per query, representing an 80 reduction. And this reduction significantly improved the computational efficiency while ensuring the recommendation remain geographically relevant to the user. So I think to conclude this research and to reduce and optimize reactive personalized restaurant recommendation system that combines the key components. First, the content-based filtering was used to generate the recommendation based on user preference and recent attribute. Second, the DB scan clustering was applied in Google platform to reduce the search space from 15 restaurant to only 61, achieving 80.6 reduction while improving efficiency and scalability. Third, the weight ranking formula was developed a combined content similarity, distance similarity, and regularization factor, producing accurate and balanced recommendation. And the experimental result demonstrates strong performance, as we discussed. So, for the future work, the model can be extended to a larger smart city environments adapted to other recommendation domains, enhance strong dynamic parameter turning and integrated with the real-time user feedback and contextual information. So thank you so much for sharing me my research and looking forward.
Thank you so much. I have a question for you. It's really interesting, your research, because I think that you can move from a touristic point of view, so asking where is the best restaurant near me or where is the best beach near me, and so on, but also with a focus on healthcare. Did you manage some data on healthcare, or it's just a future development of your research?
So can you say that, please?
Yes, of course. I try. Really interesting the possibility you shown to move from the touristic market to the healthcare market.
Oh, to the health market. Yeah.
And I'm asking if you manage some data set, national data set on healthcare services in your location, in Baghdad, for example.
Yeah. So actually, you're looking for something that changing the data set, right? Because the data set here is limited with actually we have two essential data sets. The small one is the user preference, like what the user or the customer preference, what type of the service. Let me say the services, which is generally talking about maybe I'm looking for restaurants, looking to the hospital. So now, in this case, the data set is changed because the first data set, if you look to this one, is limited by the restaurant. It shows that they're talking about maybe I'm looking for. Yeah. So yes, actually, if we take the framework or the pipeline for the model, we can just adjust some skills that we can choose in any field. Like as you said, I'm working in the health field. For example, I'm looking for the hospital. Like that's more
common to search for feedback for a restaurant or for something connected to a touristic site. And I think not so common to search in the web for a medical service, I mean.
It is commonly like in United States, actually, we have like
it's different.
Yeah, exactly. This is why like I tried to introduce at the beginning, like the motivation for this research. When I go to my home country, looking for the restaurant that comes with our preference or what we prefer to eat this today, we get struggles for that. But in United States, if you're looking for example, for the medical center or the clinic that comes with your need, you can find it. But in our model, so we have evaluation. Now the rating is high score. And even in Iraq, the research were done, so we can look for the clinic. For example, if I get like some health problem, I can look for the clinic with high rating and near to my location. So come back to our model actually we can adjust little scales, the data set for both for a user and the services we can find, because the model has no limitation to getting the data set. Like just feed the model with the new data set, then maybe we can just validate that and we can deploy that model.
That's why it's really interesting. Yes.
Is that comes with your questions?
Yeah. Thank you so much.
Any other questions?
Are there other questions from the audience, also online? Oh, here in break.
It was really interesting to see your work because the case study that I usually present to my students about data governance is exactly this platform about restaurants. It's exactly the same.
Yeah.
And so I think that your approach is pretty robust. My concerns are about how you keep the information both about the LGBT rules, so private data about the customers, not restaurants, but the private information about customers, location, name, comments. I don't know if the users just rate the restaurant from 1 to 5 or just put some comments, free text comments. How these both the rating and the comments are filtered by the system, because they might be artificially improving or decreasing the rate of a given restaurant for competition purposes. This is one aspect, and the other aspect is how.
Let us go to the first aspect, right?
Okay.
So did you talk about the confidentiality for the customer information?
Yes.
Yeah, so actually the model is working in this way. So when we deploy the model, so the user can, we have some idol, like don't sell my information, that's happening nowadays. Yeah. So when the user have the model on his website or his computer or mobile, so only the IP for his device gonna be on the model. So when retrieve the information or his request, it comes to his device. So this is gonna be done only personally between the user and the model. So nobody gonna share you, because try to imagine that this is my mobile. I have an app, which I am a designer. So I put the app, then the app, it will be installed in the user phone. So it will be only you. If you don't sell your information, nobody can see it. But in case that you want, as a user, you want to put the comment, this is something else. You will not put the comment in your personal, to yourself. You're going to put the review to the restaurant that you go. But we can improve our model. We can improve our model, or actually not improve, add some stage that I can ask you about your feedback to my model. This is going to be internally in my model, not for all. So then I can get your feedback or my client feedback to improve my model more and more. Does that make sense?
Yes, and the other aspect is how long do you keep information about restaurants? Because at least in my context, restaurants are a pretty volatile reality. So they change every 2 years or even less.
Yeah.
So just for a question of accuracy, we are very concerned about how long do we keep the information about that restaurant, because the restaurant can change the cooking personal or whatever. And so it's pretty volatile, and we are concerned about how long do we keep information for a given restaurant.
Thank you so much. This is so important question. So actually, if we come back to the system or the model, so we will not keep the data for a long time, because the data is dynamically created when the user click or enter his preference. So the data is generated like temporary. So if any update happened to the restaurant, if the owner for the restaurant updated their information in their website, I'm gonna capture that. But if not, this is their concern, they're gonna miss the customer, right? But if the restaurant owner or the company change or update their information about maybe they create another cuisine for the customer, so if they update it, so the system, let me give you the complete example. Today, I use the model with the same location. So I use like, I want to eat Italian cuisine. So I'm looking for the Italian restaurant, but X restaurant, they don't update their website to be on cuisine, Italian cuisine. So this is their concern. They miss money. We're talking about the money. So the data generated automatically every time when the user try to choose the restaurant.
Okay, I agree with you. They lose money, but your platform loses credibility because it was
yes,
suggesting a restaurant that is
yes,
not Italian or whatever. So
exactly. But this is what you know. This is why we validated our objects or our data for the modeling and experimental data. I have one of my friends in the research team actually. So they go by themselves to the restaurant that they, and validated. In database or data science, we have to validate the data about ourselves. So actually, the research team, they did their best to validate all the restaurants around Anaheim University to be sure that they updated their data just for confidentiality and for the accuracy for the system.
wonderful.
Does that make sense?
Thank you. Thank you.
Thank you so much.
Thank you.
Thank you. Now I'm introducing another presentation, Gregorio D'Agostino, Maurizio Pollino, and Alberto Tofani, with a research entitled CIRES, GIS-based platform for critical infrastructure resilience analysis in urban environment. It should be online. You can share your screen, please.
Yes. Good morning, everybody.
Yeah.
I'm in the presentation. Can you see my shared screen?
Yeah.
Okay.
Thank you.
Okay. Thank you for your presentation. Good morning to everybody. My name is Maurizio Pollino. I am the head of the Laboratory for Critical Infrastructures of Enea. And in this presentation, I will show you the development of a GIS-based platform, CIRES, devoted for critical infrastructure resilience analysis, especially focusing on the urban environment. Our platform is focused on the urban environment because the critical infrastructures can play a crucial role in life of citizens, but also in the other systems, services and delivering of power, water, transport, and so on. And in Europe, in this specific period, we have an important regulatory background represented by the Directive 2557, the so-called Critical Entities Resilience Directive. So for this reason, we developed this platform, CIRES, and I will show you some features, the architecture, some simulation capabilities, the meta modeling interface, And finally, I will present you some preliminary results in order to conclude my presentation with the future developments expected. And just to define the problem in urban areas. For example, we have the power network, which is fundamental not only for the citizens and the customers directly connected to this service, but also to the so-called cascading effects. So a failure affecting the power grid can have consequences and impact also on other systems such as telecommunication, water supply, transport, healthcare, strategic buildings, and so on. In this period, as we know, we are experiencing growing threats, especially coming from natural hazards related to climate change, such as floods, heat waves, and other natural threats, which can produce damages on infrastructures. We have also to deal with anthropic threats, such as the cyber attacks, mainly related to the digitalization of many systems of critical infrastructures. So we have considered some natural hazards in our analysis in order to develop the tools, the analysis tools within the platform. But we have also considered the deliberated attacks coming from, for example, from cyber attacks, but also the so-called hybrid threats, specific situations in which you can have a mix of natural and anthropic threats that can produce a failure in a system. All these aspects are considered by the Directive on Critical Entities Resilience. The directive is focused on not only on the physical assets, such as substations, cables, and so on, but also on the services provided by these infrastructures. So the term used is critical entity in order to comprehend both the physical asset and also the service provided. And the directive is focused on the resilience of such entities. So in this framework, we have conceived an integrated GIS-based environment in which we have an architecture by 3 layers that I will show you in the next slide. We have considered so far 6 different types of hazard. We have an informatic architecture based on Dockers, a web GIS interface, and we have decided to be compliant with the SER directive, which indicates the definition of 11 different entities, sectors to be considered. This is the representation of our architecture. In the core, of course, we have the open source suite and tools devoted to the storage of data, the database, the middleware in order to publish the data according to the OGC standards, a front end based on GeoNode framework, but we have customized all these suites and tools in order to provide different types of front end according to the different capabilities and needs of the users, which can be basic users belonging to the public administration, but also experts and scientists who want to perform a specific spatial analysis. In the back end, we have all the algorithms and methods that we have developed to perform simulations and analysis. Finally, to complete the overview of our architectures, we have a block in which we can consider all the data, so the data layer, the georeferenced information about infrastructures coming from different and various GIS formats, the information about the hazards and the maps which describes the characteristics of the specific hazard considered in our territory. In the current version, our platform is focused on the Italian territory, of course. And we have also defined the interdependency graph in order to consider the mutual dependencies between different systems and infrastructures. And all the data are stored in a PostGIS database. Then we have the simulation layer in which, for example, we can simulate earthquakes, we can perform multi-hazard analysis, and we also can consider issues related to the geological instability in terms of subsidence or landslides that can impact on linear infrastructures such as roads or pipelines. And then the presentation layer is represented by a WebGIS user-friendly interface in which it is possible to access and query thematic maps, dashboards, and to perform analysis, create risk scenarios, and so on. Another aspect is related also to the meta modeling of our tools. And in one of the next slides, I will show you an example of such a kind of modeling. Considering the scenario, currently we have implemented a seismic scenario in which it is possible to define, starting from some parameters related to the event, such as the hypocenter, the hypocenter coordinates, the depth of the event, the magnitude, the propagation law. It is possible also to simulate the level of damage of structures, of infrastructures in a specific area, also taking into account the fragilities curves that can take into account the specific vulnerabilities of these elements. We have also defined a tool to perform the multi-hazard analysis of infrastructures. We have also created a tool to evaluate the possible impacts of subsidence or landslides on infrastructures, linear infrastructures. And also we have, finally, this is also the the case study that I will show you at the end of this presentation, we've also combined two different typologies of threats, natural and anthropic, in order to create a hybrid threat that trigger the damage on an infrastructure, and also to evaluate the cascading effects coming from the primary impact. This is an example of the visualization of the multi-hazard analysis tool in our platform, in which it's possible to combine an approach based on weighted linear combination. Thanks to this approach, we can assign a different weight to each different hazard considered, and the idea is to analyze the coexistence in the same area of these 6 different hazards, and the geospatial analysis by overlaid the geographical and topological elements of infrastructures such as roads, bridges, railways, power substations, gas pipelines, towers, and so on. So at the end of the simulation, the platform is able to provide you a detailed report of this analysis, along with a GIS map representing the overall multi-hazard level and also the single hazards levels. This is an example of the geological instability tool, in which we combine information coming from the Italian inventory of landslides and the Italian mapping of landslide hazards. And also we consider in this tool the persistent scatterers produced by the Copernicus European Ground Motion Service. So at the end of the analysis, it is possible to produce a report and a GIS map in which for each element of a road or for each asset such as a bridge considered in the analysis, we can define the possible subsidence phenomena related to the ground displacement monitored by satellites, and also to put this phenomenon in relation with the existing landslides in the surrounding areas, or the landslide hazard mapped by the Italian landslide service.
Maurizio, sorry, can you hear us?
Yes, I can hear you.
Okay, so if you can go to the conclusion.
Okay. So briefly, this is an example of meta modeling. We have defined specific single processing tools such as blocks, and so we can combine define workflows in which each block, each module perform a specific analysis. For example, data ingestion, GIS overlay in order to define the hazard, to assign the level of hazard to an infrastructure, and also, for example, other more sophisticated analysis in order to define the risk level. So you can build up also more structured workflows, and this is the operational philosophy behind our developments. This is an example of the pilot study in which we have considered a failure on the electrical grid coming both from an anthropic threat and also a flood, and the cascading effect because the water supply network is depending from the power delivery. And so I jump to the maps. This is the web interface in which you can simulate the flood and the impact on the power substations, the effect and the cascading effects on other infrastructures. And in the last table, it is possible also to individuate the the water supply network pumps affected by the electric failure. This is the resilience calculation, and this is the final map. This is the very last slide. We have currently developed a GIS-based platform able to manage different kind of critical infrastructures and to perform spatial analysis in order to simulate the impact of natural hazard or anthropic threats on each asset. We are compliant with the European SER directive, and the future work is to expand our container library considering other threats such as wildfires, and also to take into account real-time data to perform machine learning analysis for detect possible patterns in cascading effects, and also to realize a digital twin of an urban area in order to take into account all the aspects also related to the population and to the services in these test areas. Thank you for your attention. This is the URL of our platform, and along with the other authors, I will thank you for your attention.
Thank you. Thank you, Maurizio. And are there any questions from the audience? Here in presence, no. Online, very briefly. Sorry, but it's late. So, okay. So we can move to the next presentation, and Marco Antonio wrote in the chat that is the next presenter. So welcome. I leave the floor to you and for the contributions entitled Artificial Intelligence for Photovoltaic Power Forecasting in Energy Management. Please, in 10, maximum 15 minutes, to have some time also for the debate. Thank you.
Good morning to all of you. And I will start sharing the slides. I think you all are watching the slides.
Yes.
Yes?
Yes.
Okay, so I am a researcher, a data scientist from the Technological Center CTC located in Cantabria, Spain. And today I will present our work on artificial intelligence for photovoltaic power forecasting. The central idea is simple. Forecast is useful when it helps us make better energy management decisions. This is especially important in PV installations where surplus energy cannot be injected into the grid. In Spain, at least, this zero injection restriction is a practical concern for many installers, suppliers, and users. So the problem is not only academic, it is operational. The motivation of this work is not forecasting for its own sake. Photovoltaic production changes with the weather conditions and also with, of course, the installation conditions. In a zero injection installation, any surplus must either be consumed locally or curtailed. By curtailed, I mean that potentially available PV production is intentionally limited because it cannot be used or exported. A forecast gives us information before this happens, and that information can be used to plan flexible demand. This problem appears in many current energy applications. For example, in building digital twins, the forecast can coordinate HVAC systems, batteries, or electric vehicle charging. In industrial energy management systems, it can help schedule pumps, compressors, or thermal loads. And in green fuel or conversion systems such as electrolyzers or CO2 conversion units, it can adapt the operating window to expected renewable availability. And the common structure is always the same. You have a local PV generation, then controllable demand is required, and you have to deal with the weather uncertainty. The objective was to develop a short-term photovoltaic forecasting model using real data from a pilot installation here in Santander. And for that purpose, we combined historical PV generation with meteorological variables. And the contribution is not only the predictive model itself, as I said, but the idea is of converting raw measurements into decision-ready forecasts. In other words, the forecast should become an input for action, especially in energy management systems affected by zero injection constraints, as I said. The main case study then is here the installation in Santander, and this is a useful test case because weather conditions here can change quickly, especially due to clouds and irradiance variability, and that makes the prediction problem more challenging and more realistic. In our study, we used 1 year of measurements, which covers a complete seasonal cycle. For an initial prototype, 3 to 6 months can be enough. But for a serious operational study, I would recommend at least 1 year, and ideally 2 or 3 years for a stronger generalization. A key point is a key point that is sometimes missed is that weather data is needed twice. First, historical weather data is used to train the model together with the historical PV production, and second, future weather forecasts are needed during deployment because they become the future exogenous inputs for the model's predict function. So the model can only forecast the future if we also have future values of radiation, temperature, wind, or precipitation. That is why we screened sources such as ECMWF Open Data, Open Meteo, and AEMET, which is here here the price which give in Spain the prediction meteorological predictions, and why these sources should be benchmarked against the local stations before deployment. A practical lesson from this work is that preprocessing is not a secondary step. Before making the model complex, the data must be operational. First, check data access is key. API availability, for example, before to buy the stuff, data ownership and sport limits, and real-time access and cost should carefully regarded before. And second, align all data sources in a common time index. Third, to control quality issues such as missing values, duplicated timestamps, sensor dropouts, and anomalous daytime zero values. For deployment, preprocessing must be automatic and reliable, not just a manual cleaning notebook. There are several model families for photovoltaic forecasting. Statistical and physical models, such as persistence or clear sky models, are useful baseline. Neural models such as LSTM or GRU networks can be powerful, but they often require more data and tuning. In this work, we selected a tree-based approach, specifically an XGBoost with SK forecast library of Python. And the reason is practical. We can explicitly define the lags, combine them with the weather variables, and audit the model using feature importance. The exact code is restricted by company confidentiality policy, but the workflow follows a standard and reproducible time series machine learning structure, like the public repository given here in the link of at the bottom. And yes, the feature importance analysis shows that the nearest lagged values, lag 1 and lag 2, are the most influential predictions. This is very logical. And this is expected in short-term forecasting because recent PV production is highly informative. At the same time, solar radiation appears as the most relevant physical exogenous variable. And this is important because it shows that the model is not only repeating the past, it is also using physically meaningful meteorological information. After training, we need to check whether the model is learning patterns to generalize rather than simply memorizing the training data. Here, the training and validation errors evolve consistently without a strong overfitting signal. This validation step is the first operational safety check. A model with a good training performance but poor validation behavior should not be deployed for energy management decisions. And in terms of test performance, the model achieved an R squared score of 0.92, and this is the nearest to 1, the better. And with also another metric, MAE of 16.52 watts, and also another metric of RMSE of 14 watts, and approximately this corresponds to 2 and 5 of error respectively. The 48-hour example shows in this graphic shows that the model captures the main daily production profile, and this result is especially relevant because Santander has a variable weather conditions, so the forecast must deal with rapid changes in irradiance production. This slide is the most important practical point, because the forecast becomes useful when it is transformed into operational indicators. Instead of only predicting every individual time step, we can aggregate the forecast into, for example, morning, afternoon, or daily expected production. And these indicators can guide load scheduling. If high PV generation, for example, is expected in a given window, flexible loads such as HVAC, EV charging, or pumps, or compressors, or electrolyzers, or non-critical tasks can be moved or intensified during that period. The forecast should be seen as part of a decision support loop. A day ahead forecast can define the initial schedule. Then intraday updates, for example, can correct the plan as new weather and PV data arrive. Anti-sport hardware remains as the safety layer, but predictive management adds before that safety layer is needed. The goal is to reduce unnecessary curtailment and increase self-consumption. In future versions, uncertainty bands could help decide when the forecast is reliable enough to schedule flexible loads.
Antonio, sorry, 2 minutes left, no more, please.
Okay, to conclude, there are 3 take-home messages. First, real pilot data can be used to build an accurate PV forecasting model. Second, interpretable tree-based model are useful because they combine performance, explicit lag design, and feature importance. And third, the value of the forecast is operational. It supports load scheduling, digital twins, and energy management systems. And the next step are to integrate, for example, IMET forecast at uncertainty bands, as I said, and use rolling horizon correction, and connect the forecast to a load optimizer. And thank you very much for your attention, and that's all.
Thank you, Marco. We have a question here in presence for you.
Yes. Yes. Can you repeat, please?
Thank you. Can you hear me?
Yes. Yes. A bit low, but yes, I hear you.
So thank you for your presentation. I think that your model can accurately predict the photovoltaic generation, but energy management also depends on the pattern of consumption. So just
yes.
Okay. Have you explored also how can this AI model can include also the prediction of user demand to optimize the overall system for the photovoltaic generation?
Sorry, can you repeat, please?
Have you explored how AI can also include the prediction of user demand to optimize the overall system?
Yes, yes. The idea is to have both a model of prediction for generation and also another model of prediction for demand. And
Okay.
you combine these two predictions to this load scheduling to ensure you take advantage of the maximum energy that will be produced in the near future. Yes.
Okay, thank you so much.
Thank you to you.
Are there other questions?
Yes.
Wow. Okay. Yeah, go there because now the webcam is correctly centered.
Okay.
Nice.
Hello.
Hello.
Thank you, Michael, for your presentation. I have just two concerns or two questions or something that I want to share with you. First is, since the photovoltaic production is, we know that is mainly a consequence of solar radiation. My question is, I would like to know what is the advantage from the medical perspective of including other environmental variables, and what is the gain to include long time series like months or years to estimate the photovoltaic production.
Yes. Okay. I barely understand. I will. Okay. I will. Let's see if I understood your answer. You are asking if this this algorithm can what advantage can present to when added to this zero injection installation, right?
No, my question is, I would like to see a kind of a baseline that is, I will predict the tomorrow photovoltaic production based on prediction of tomorrow solar radiance. Just that, just you know, a computational, a baseline with a computational effort of 0 or like to 0. And then add some other variables, some more time for learning or whatever, in order to have a kind of a table that shows how prediction performance improves based on the cost of that prediction.
Okay, including I don't know if the noise it is a bit of noise, but you're asking if the irradiance. Okay, what is the cost of including the irradiance to the prediction or the future irradiance? You know, or future meteorological variables to this prediction, right?
No, I have your email. We will talk later. Thank you very much.
Sorry. Okay. So thank you. Thank you. It is present a bit of background noise.
More question. Thank you so much. So we are moving to the last presentation.
Yes, you can. Sorry, just a bit thing. You can see details of these variables and how it's affecting the algorithm in the of course in the article. It will be published in some days. Yes, and I am sure that this will respond your answer, your question. Yes, your question.
Thank you so much. Thank you so much. Now I leave the floor to Laura Di Tommaso. for the last presentation of this session entitled The Tourism Assessment and Participation in the Tourist Destination Transition, a Literature Overview. Laura, you can share your screen.
Good morning. Yes. Do you hear me and do you see me?
Yes. See? And also your presentation. Thank you so much.
Okay. Do you see the screen?
Yeah.
Okay, perfect. Okay, good morning to everyone. I'm Laura Di Tommaso, and today I'm presenting a contribution developed with my colleague Piero Zizzania on the coordination of Professor Maria Cerreta. The presentation is articulated into 5 sections. In particular, I will describe the research context, the introduction, and after the methodological approach and the main findings. And finally, I will have a brief discussion and conclusion. This paper is part of the guest doctoral research project. The research aims to identify through the exploration of advanced evaluation methods and approaches, strategies for sustainable transition in marginal areas under tourist pressure, with a particular focus on the contribution of local communities to self-determination of the destinations. And this article is part of the first phase of the desk-based research, which focuses on the exploration of the literature. The research objective lies at the intersection of 3 disciplinary fields. The first is related to the field of urban studies, which examines the transformations of cities caused by tourism. The second concerns the role played by local communities as key stakeholders in decision-making processes. And the third is the field of evaluation, obviously, which is in recent years sees the evolution methods and approaches, placing evolution at the center of the debate on the design of urban transformations. Considering the first topic, we can introduce it very briefly. As we know, a complex set of issues like transport, communication, and hospitality changes has led the democratization of travel. These include, for example, the platform economy growth. And this phenomena has produced multidimensional changes to our cities. These impacts are generally described as over-tourism or unbalanced tourism, but really they represent very different part of the same issue that consists in our tourist cities. In respect to the public place, we can see its gradual erosion supported by the proliferation of outdoor dining areas and the change of the use of ground floors, a phenomenon that we know as foodification. But considering real estate market, we are seeing an increase in the number of B&B, for example, which reduced the number of houses on the real estate rental market. So, and another problem is related to the city's identity, because it's gradually replaced by tourist imaginaries. This is exacerbated by social media, where the narrative of the city is produced by tourism than the residents. In a process of progressive folklorization, we can say that transforms cities into like theme parks. The second point is related to the role played by local communities. Indeed, tourism and culture drives communities to express resistance through various types of protests. So the concept of tourismophobia was coined by the social media to describe the spontaneous but sometimes aggressive, we can say, reactions in context under high tourist pressure, giving to these people a negative connotation. But this definition contrasts with the principle of community engagement, which is not now recognized by European policies, in particular for the just transition. And indeed, the role of communities can be very central in sustainable transformation of cities, but has to be better explored in the field of tourism. Finally, as regard to the evaluation frameworks applied to tourism dynamics, as we know, there is no a single approach, but a range of different evaluation methods and models. Over time, researchers developed different tools, technique, methodology, and starting from the ATIS, that is the main European framework, there are several evaluation approaches for different goals. like hedonic method, willingness to pay, regression analysis, etc. We have also carrying capacity model. And in recent years, innovative and integrated approaches have also been emerging, but nevertheless, the literature of this subsector remains a bit fragmented. So this paper analyzed the link between tourism dynamics, the role of local community, and the assessment through a literature review, which also employs bibliometric techniques. To this end, the paper explores how actor research trends in the adoption of participatory evaluation approaches to the assessment of tourism dynamics. And the review also seeks to identify which areas of research are saturated or have not been sufficiently explored. So the methodology is articulated in 3 parts and was supported by 2 tools, Voice Viewer and Voyant tool. The first phase was used to select a set of 1,102 papers based on a scientific query on Scopus. The second phase involved the analysis of a scientific landscape, and we selected 20 most relevant articles. And finally, the last phase is a critical analysis of these 20 papers based on 3 identified topics, so evaluation, tourism, and communities participation. Starting from a first general study exploring academic and non-academic literature, we identified the main themes of the review. We also identified the most useful database, that was Scopus, as I said. And starting from the identification of the main fields, a search query was defined and the 3 main tags were identified. I want to say that we divided the topic communities participation in 2 tags. So community and participation. Furthermore, the results of the initial research related many articles regarding the pandemic period. So we decided to exclude some terms related to COVID to have a better collection. And so after some filters regarding to the year, subject area, and type of articles, we had the collection based on 1,102 papers. The second phase, the phase B, which was the bibliometric analysis, was carried out using Voice Viewer, as I said, to identify emerging research clusters and the main thematic nodes in literature. To this end, the database was imported in the software, and we developed a concurrence network between terms extracted from abstract keywords and titles. We also created a thesaurus to optimize the vocabulary, followed by a database cleanup. And in conclusion, we had a collection of terms made by 222 terms. Finally, 2 subgroups were examined in depth, including the 50 Scopus most relevant and the 50 most cited papers, always by Scopus. And a criteria system based on 3 dimensions was developed and included research scope, evaluation aspects, and participatory issues. And we used the Voyant tool was used to analyze the frequency of terms used in the articles to help verify the selection of contents. The text of each article was imported into Voyant, and the 5 most frequent words were selected to develop a thematic classification of the documents. So each article was assessed according to its relevance to the research topic using a 5-point Likert scale. This enabled to develop a ranking, which we selected the 20 most important articles to explore in a better way. So starting from the results, the first article analyzed to identify general information about the scientific production, for example, related to the countries or the number of publications in the years. And looking at the cloud, the general cloud, we can see that the central issues are related to sustainable tourism and cultural heritage, but we also have found some niches as gender dimension, multi-human approach, or interplay between tourism and AI. The papers mention different tourist models, And the most interesting maybe is community-based tourism, because it was new related to our first exploration of the literature. In the cloud, we also find some participation tools like interviews, surveys, or social media. And regarding to the evaluation field, the cloud is aligned in the team of impacts related to many different levels, but no multi-criteria methods are mentioned. And the terms values is connecting only to the terms of co-creation and destination image. After this exploration, we concentrated our attention to the 100 papers selected. In this, we have found a specific attention to coastal and island areas. And many papers are also related to different specific destination governance models, as DMA or STD. There are also some growing niches, and in particular, we find a new one related to destination branding. Related to the evaluation field, the evaluation approach has several, but many articles consider regression analysis. So we have most of the articles are related to few evaluation approaches. Finally, look at the collection. We can see that are generally considered 8 types of stakeholders, but the role played by university and natural ecosystem is very secondary. After this exploration, we have studied more in detail 20 more interesting papers, as I said. Many studies focus on the tourism impacts of major destinations, or in other cases, tourist perception between residents in tourist and non-tourist places. Other researchers concentrate their attention to evaluate the effects of implementing community-based tourism models, and some of them assess the destination's performance considering specific sets of criteria. Others try to assess if community active participation in tourism improves residents' tourism perception in destinations. And lastly, some studies evaluate the destination's image role in tourism development, considering how it can influence visitors' travel choices. The analysis carried out as highlighted the evaluation landscape, which still exhibit many limitations, we can say, but in the evaluation tools and in participatory approach, there are very many limitations. In particular, few studies assess the co-design and co-governance impact in destinations. And none of them studies examines how community involvement might facilitate the detouristification of metro over tourist destination. So the application of integrated evaluation approach is limited, and this is often considered as a tool for ex-post impact analysis rather than a planning tool. Another aspect is then many of the study contexts are large tourist cities. In this regard, some exceptions focus on the small islands or small little places, trying to test innovative approach in marginal context. These studies try to interpret marginal and islands areas as particularly useful to identify small-scale strategies for tourism resilience, and this is very interesting, I think. Talking about citizen engagement, many contribution describes a community involvement really partial. This can be methodological fixed by considering spatial multi-helix models applied to tourism context. At the same time, the engagement tools are very limited. It might therefore be useful to explore studies that employ more innovative engagement approaches, such, for example, living labs. And considering tourism development, no study aligns with new perspective like the growth theory or Donut model that could represent a useful direction to fix. I want just very briefly highlight some limitations that we have to consider in this paper, because firstly, this research is not a systematic literature review, as although it follows a clear methodology, but this not fully aligned with established methodologies like Prisma. Secondly, the analysis considers only those publications available on Scopus. We have not considered articles presented in Web of Science, on OpenAlex, or on others. Furthermore, the study is limited to a specific time period, includes only certain type of publication, this might maybe it could be excluded other relevant or useful contributions. And finally, only 2 tools for bibliometric and content analysis were used. We recognize that other equally effective tools exist and the other types of analysis are possible. And here I leave some key bibliography providing some background information of your paper, and I conclude. So thank you for your attention. So if you have questions, I'm very happy to listen to you.
Thank you very much, Laura. Any questions for the audience? No more questions? Alice? For me, it's a really interesting research. I think that in the next hour session, this afternoon, you will find some gaps that you mentioned before. I mean, the participatory gaps that we, as a group, a research group, we find in the Valsesia contest. So I agree with this particular liberty. No more questions? So maybe we can conclude.
Yes, the second part of the evaluating mineral potential will be at 2 in this afternoon.
Plus 2.
2?
Okay.
2 p.m. And so thank you everybody for your attention, and I think we can go fast to the keynote presentation. So thank you very much.
Thank you. Bye bye.
Bye, Maria.
Thank you very much.
Bye. Thank you. Have a nice day.
Have a nice day.